All right, today we're going to preview topic 9, which is long division, and we're going to start with reviewing some vocabulary from previous lessons. Choose the best term from the list on the right, write it on the blank. To find an approximate answer or solution is to, what do we want to do to find approximate answer or solution? And if you thought it was estimate, you are correct. The fractions 3/4 and 17/4 are fractions with like denominators. They both have a 4 in the bottom. The denomination is the same. They're fourths. One is 3/4 and one is 17/4, but the denominations are the same. They're fourths. Number 3, the fractions that name the same amount are equivalent. So we call them equivalent fractions. The answer to a division problem is always a quotient, and a number that has a whole number part and a fraction part is called a mixed number. Now, if those were all easy for you to get, then you have a good foundation of the vocabulary we'll be starting out with on this chapter. Moving down, we're going to be looking at some other concepts that will help you in this chapter. Each rectangle represents one whole. Write the shaded part of each rectangle as a fraction. First, we want to think about the denominator. So the denominator is going to be the total number of boxes or shapes here. So in this case, we have a 2 by 1, 2, 3, 4, 5, 6, 7. A 2 by 7 would be 14 altogether. And how many are shaded? 11. So we would call that 11/14. The denominator for number 7, the total number of boxes, goes in the bottom. Oops, which is not 9. Sorry, gang. It is 6. And the total number that are shaded is 4, and we can write that in lowest terms as 2/3. And remember, lowest terms, we're going to look for a factor that will go into both numbers and divide by that so we can get our lowest term fraction. Fraction computation. Find each sum, difference, or product. So we have a little work to do here. So we're reviewing addition and subtraction and multiplication of fractions. So for number 8, we have 2/5 plus 1/4. We see 5 and 4 are different. We need to find a common denominator. Rename the fractions. And then perform our operation, which is addition. So 13/20. For number 8, 13 is a prime number. 13 does not go into 20, so I know that fraction is in lowest terms. 5/6 minus 1/4. The denominators are different. I'm going to start counting by 6s. I'll hit 12. 4 will go into that. So that is the smallest number that both of them will go into. And now remember, my operation is subtraction here. Again, 7 is prime. 7 doesn't go into 12, so I know that cannot be reduced. Number 10, 2 and 5/8 plus 7 and 1/4. I know that 4 can go into 8, so I'll just rename this fraction. Then I can add, and I have 9 and 7/8. For number 11, whole number 14 minus the fraction 3 and 5/8. And remember, when I do these, I need to make sure I remember if I don't have anything here, I have to get something here. So I'm going to borrow, and I'm going to borrow in the form of eighths because I already have an 8 down here in the denominator. So 8/8 minus 5/8 is 3/8, and 13 minus 3 is 10. And 3 is prime, and it doesn't go into 9, so I know that is in lowest terms. Get some more space here, so that was number 11. So now we're going to scoot over to number 12. 3 and 2/3 plus 4 and 1/2. My denominators are different. Common denominator for 3 and a 2 is a 6. Got to rename, add over here. And when I get to this part here, I'm going to need to take my 7 sixes and turn it into 1 and 1 6, and then add it back to that 7. So I have 8 and 1 6 is my final answer. 13, I have 3/8 times the whole number 2. I can throw a fraction under that, multiply the top, multiply the bottom. In this case, 2 even numbers can reduce by 2 over 2, so I'll get 3/4. Number 14, 1/4 times 3/5. Multiply the numerators, multiply the denominators. 3 is prime, and it doesn't go into 21, so that fraction is in lowest terms. And what am I on now? 15, the whole number 8 times 9/10. Just going to throw a 1 under there. 8 times 9 is 72 over 10. And remember, 72 over 10 means 72 divided by 10. How many times does 10 go into 72? It goes in 7 times. And I'm going to have 2 little guys left over, 2/10, which can be reduced to 1/5. So my final answer is 7 and 1/5. Number 16, 3.5 times 2 and 3/5. I'm going to turn those fractions into improper fractions. So 2 times 3 is 6, plus 1 is 7. And I just put my denominator there. 5 times 2 is 10, plus 3 is 13. And I'm going to multiply that out. 17 times 3, or 13. I know 7 times 10 is 30. Or 7 times 10 is 70, and 7 times 3 is 21. So I'm going to have 91 over 10, which will reduce to 9 and 1/10. I use a distributive property here. 9 times 10, or 7 times 10 is 70, and 7 times 3 is 21, to actually multiply that in my head. But you can also do the algorithm off to the side, which is fine. So that was number 16. And that is the preview for topic 9.